Welcome back. In this section, we're going to be covering engine reassembly procedures. And, for example, we're going to be using the Sea-Doo 4Tech engine, the 1503. First thing I want to talk about is a very basic but very important item, and that's cleanliness. Ensure that all the components that you're working with are clean. You also need to be sure that all the gasket mating surfaces are free of any old gasket material or oil or grease. Now, let's start with these nice clean rod bearings. First, you need to ensure that the backs of the bushings and the machine surfaces are clean, that there's no gouging, no scoring, no marks. Then you want to install the bearing by rolling it into place like this. You do that on both halves. This one goes this way. Now, to be sure that the tang is completely locked into place, there should be a small amount of bearing protruding from the other side. You can see this here. Now, this will help keep pressure on the bearing to keep it from spinning when they get bolted back together. Now, the next very important item is to make sure that all the friction surfaces in the engine are well lubricated at assembly time. Now, if you're going to start the engine right away, you can use engine oil, like I have here, or if it's going to be a while, you might want to use a good engine assembly lube. Now, this will ensure that the engine will have sufficient lubrication while the engine builds to its initial oil pressure. The next thing we're going to do is install the piston rings. The first one is this oil control scraper ring. Now, be sure to install the ring with the mark here towards the top of the piston. If the ring is installed upside down, oil will pass by the ring and the engine will end up consuming oil. And you would use a piston ring expander to carefully expand the ring and place it over the piston and then into the groove. Then you'd proceed with the other rings. Now, you always have to make sure that the mark that's on the ring is in the up position, like you can see here. Now, let me just finish installing this last ring. There, now that that's done, it's time to install the piston. So give me a few minutes and get myself set up over there, and we'll take care of that. Next, we're going to have to make sure that it's properly lubricated, both around the rings. You also need to lubricate the cylinder as well. So once that's done, you need to make sure that the ring end gaps are staggered, so they're about 120 degrees apart. One here, and one here, just like they show you in the shop manual. Now, I'm going to use this ring compressor to collapse the rings into the grooves and make sure that they're completely compressed, and then slip it into the cylinder. Making sure naturally that your arrow is in the right direction. Everything should slide right in. Now, you want to tap around the edge of the ring compressor to make sure that it's flush. Next, be sure that the rod won't hit the crank journal. And once you've done that, you can tap it with the end of a hammer onto the piston like this to move it into place. And there it is in place. And the next step would be to bolt the rod caps back in place and to torque down the caps. So then we would do the same procedure for the rest of the pistons. Let me finish that up, and I'll come right back and we'll go on to something else. Now, before I put this last bolt in place, let's take a minute and talk about proper fastener retention. Now, there are several procedures that can be employed to determine how much tension is actually exerted on a fastener, using a torque wrench, measuring the amount of stretch, and turning a fastener a predetermined amount, which is the torque angle method. It's important to note that in order for a fastener to function properly, it has to be stretched a specific amount. When the bolt has stretched that specific amount, the correct preload or clamping load has then been applied. Now, the material's ability to rebound, like a spring, is actually what provides the clamping force. If a fastener is over-torqued and becomes stretched too much, you have exceeded the yield strength, and then it's ruined. If a fastener is longer than manufactured, even if it's only 1/1000th of an inch, it's going to be partially failed, so you want to throw it out. As a result of this, many of our fasteners are not to be reused. Bolts such as these connecting rod bolts and these rocker shaft bolts. Some bolts have measurements listed in the shop manual, like this head bolt. So check our publications to be sure which bolt is which. Now, we currently employ two methods of torquing the bolts. One is just by using this torque wrench, and one is by using the torque wrench and this torque angle gauge. We're going to take a look at both of these methods. And just a short note about torque wrenches. It is possible, even for the most expensive of torque wrenches, to lose accuracy. We've seen fluctuations as much as 10 foot-pounds of torque from wrench to wrench. So please have your torque wrench checked periodically for accuracy. Now, the first method we're going to talk about is using a torque wrench. If the fasteners must be installed by torque alone, there are certain factors that should be taken into account. First, there's the friction factor. The friction factor changes from one application to the next. It is affected by dirt or old Loctite on the threads, or whether the bolt is lubricated or not. So always be sure to clean the bolt threads carefully before reinstallation. Now, the lubricant used is the main factor to determine friction, and therefore a particular torque for a particular installation. Oh, good point. Thanks, Chuck. Be sure to check in your shop manual for the particular torques that you need and the lubricant required, because without the correct lube, the required torque can be reduced as much as 20 to 30%. And it's also important to keep in mind that the reverse is also true. If the torque value has been specified for a dry fastener and a lubricant is used, well, the torque's going to be increased. So let's talk about the torque angle method. Since the amount that a bolt or a nut advances per degree of rotation is predetermined by the thread pitch, the amount of stretch in any given bolt or stud can be accurately predicted by measuring the degrees of turn from the point where the underside of the bolt head or nut face contacts the work surface. Termed the torque angle method, this procedure has long been the standard of automotive use. The torque angle method is accurate only if each individual installation has been previously calibrated by direct measurement of bolt stretch. When using this method, you start the rotation from some small measured torque somewhere around 10 foot-pounds, rather than the first point of contact with the work face. So what I'm going to do is I'm going to show you this procedure, putting back this rod cap bolt. So let's go over, bring this. Now, when we're installing a new bolt, I'm going to start by torquing this down to spec, and in this case, it's 33 foot-pounds or 45 Newton meters. So I'll just finish with these bolts. That's that, and the last one. Okay, now, then I need to install the torque angle gauge, like this. The socket goes on there, and I need another wrench. And I'll get this down in place. Now, this gives us a very accurate clamping force. Now, the next thing we're going to do is we're going to seal the engine. So give me a few minutes, I'll get set up for that, and we'll come right back and do it. Now, I've checked with the shop manual, and I see that this engine is sealed with Loctite 5910. Now, this is a silicone-based RTV, or room temperature vulcanizing sealant. RTV is an aerobic sealant that cures in the presence of air. So before I start to apply any sealer, I want to make sure that I have all my bolts and all my tools ready. Speed is essential here. If I wait too long, the sealant will begin to cure. So first I'm going to clean the oil passages and make sure that they're not clogged. Now, this can be done with a bore brush. I've got a couple right here. Then I want to clean all the metal components in a solvent. The engine block mating surfaces can be cleaned using a combination of the chisel gasket remover and a brass brush. First, brush a pass in one direction and do a final brushing perpendicular, or 90 degrees, to the first. To remove the old silicone, you can also use a small rubber disc, like this one here, hooked up to a power tool. The bottom line is you don't want to use anything that's abrasive that could damage this surface. And remember this, when you're beginning the application of the crankcase sealant, the assembly and the first torquing all need to be done within 10 minutes. So it's suggested that you have all the tools and things you need on hand in order to save time. It's also recommended when you're applying this specific sealant to get as uniform an application without any lumps as possible. Now, don't use Loctite 515 or 518 to seal the crankcase. And you don't need to use Loctite Primer N with the Loctite 5910. Using these products or any other non-silicone based sealant over an engine that's been previously sealed with Loctite 5910 will lead to poor adhesion and possibly a leaky crankcase, because these products are chemically incompatible. Even after a cleaning, the Loctite 5910 would leave incompatible microscopic particles. So let me install my sealant, and then we'll come back and we'll put the crankcase back together. Now, the sealant curing time is similar to the Loctite 518 without using the primer N, which is 4 to 24 hours. Now that the case half is installed, we need to apply Loctite 243, which is the blue one, on the threads of the bolts that we're going to be using. You see, Chuck's already got these all set up for me. Next up is to run in all the screws. So I'm going to do that, then I'm going to come back and tighten them all down to spec. Then you tighten the engine block screws according to the torquing sequence that you find in your shop manual. Now in this case, it's a 3-step sequence. First, I torque these center bolts to 40 Newton meters or 29 foot-pounds, and in a second sequence to 55 Newton meters or 41 foot-pounds. Then I do the outer bolts to 22 Newton meters or 17 foot-pounds. I've got my last one to go. Let me do that. There it is. Now again, you have to follow the sequence. And remember to follow the sequence for all the other components that need to be installed as well. So we're almost done assembling the bottom end, and then we'll move on to the top. So give me a few minutes and let me finish that. I'll flip this block over and we'll get to the top. Now that the bottom end's all done, we've gotten a head start on the top end. We've installed the cylinder head without the camshaft or the rocker arms and done our torquing as to spec. But before the camshaft is installed, what we need to do is lock the crankshaft with this locking tool. And the hole for that is right here. To use it, first install this tapered end into the hole, and you're going to rock the crank back and forth until it drops into place. And when it does, you turn it down and your crank is now locked. Next, we're going to install the camshaft. Now, this camshaft needs to be coated with Isoflex grease before installation. So let me do that. I'll get my grease, and we'll come back and put it in place. Now with the cam journals all covered in the Isoflex grease, it slides right into place. Then it's time to put your locking plate in place, and that should drop in. Now, if this isn't put in on the right side, you won't be able to do the next step, which is to place your camshaft locking tool. Let me find my spot, and it should drop right into place. Now the rocker arm assembly can be bolted into place, but remember, if this procedure is not followed prior to the installation of the rocker arms, serious damage can result to the valve train from the valves contacting the tops of the pistons. So let me just bolt this into place. We'll come back for our next step. And now we're ready to do our timing procedure. Remember that all 4-stroke engines must have the cam timed to the crank, and the procedures vary from engine to engine. So of course, refer to your shop manual for the procedure on the engine that you're working on. Now we're going to use this engine as an example. First, we've got the cam and the crank locked in place. Then we'd slip the gear and the chain into place like they are here. And we need to make sure that these marks are facing out. You also need to make sure that these two lines line up with the edge of the head. Then you would install these bolts, but don't tighten them just yet. First, you have to put in the chain guide, which slides right in here and clicks into place, and then the chain tensioner, which goes over here. And there you go. Now it's time to torque these bolts to spec, so let me do that. And everything's in place. And that's it. The chain's timed, and now you can remove the locking pins, one here and one here, and continue with the engine assembly. Now, this particular engine that we've been working on has hydraulic valve adjusters. Now, this means that the clearance between the rocker arm and the tip of the valve is automatically compensated by oil pressure. In other words, there's no valve adjustment on this model. But on some engines, like one over here, the clearance has to be adjusted manually. Let's go take a look and see how that's done. Now, this engine has camshafts where the lobes act directly on these shim buckets, and they're located at the top of the valve. The adjustment for this engine is performed by replacing these adjustable shims with ones of different thicknesses. So first what you need to do is check the clearance between the back of the lobe and the shim bucket. To do that, I need to be at top dead center on the compression stroke. And to get it there, I need to begin by removing the center plug here on the right side engine housing cover. And then I'll move the crankshaft into the top dead center position with an Allen key inserted into the end of the crankshaft like this. And I turn it until the lobes are pointing in this direction and the lines here on the back are aligned. Once that's done, I'll use a feeler gauge to check my valve clearance. Now you need to record the valve clearance. If the adjustment is out of spec, it would be necessary to change the adjusting shims. To adjust the valves, remove the camshaft bridges and then the camshafts. Remove the adjusting shims and then clean them. They must be perfectly clean for an accurate measurement. Then you'll check the thickness of your adjusting shims using a micrometer. And after that, either add or subtract the number of the measurement to get back into spec and select the next shim that you'll need. For example, the valve clearance on this engine is 0.10 to 0.15 millimeters or 4 to 6 thousandths of an inch. If I checked the clearance and it measured, say, 0.076 millimeters or 3 thousandths of an inch, I would then need a thinner shim. So if the shim that was installed was, say, 2.4 millimeters or 0.094 inch, I would then need to go to the shim selection chart and select one that's 0.05 millimeters or 2 thousandths of an inch thinner and install that one into the engine. So then I would reinstall the camshafts and recheck the measurements, and that would put me right back into spec. Now, if I was working on this other engine over here, it's a different procedure. Let's take a look. Now let me just grab this engine and I'll bring it a little closer so we can have a better look. This engine has a mechanical screw right here on the end of the rocker arm. To adjust it, first I have to put the engine at TDC, or top dead center of the compression stroke. Then, using a screwdriver and a wrench, I need to loosen this lock nut. Let me just get in place for that. There we go, that's loose. Then I'm going to insert a feeler gauge between the rocker arm tip and the tip of the valve stem. Get my proper one out here. And what I want to do is turn the screw until the appropriate clearance is obtained. And for me, in this case, it's 5 thousandths of an inch, which is right there. Being careful not to move anything, we've got to get our wrench back in place, hold the screw in place, and lock it down. And that's all there is to it. Recheck that you're still in spec, and that's it. That's all there is to it. And that's it for the engine assembly procedures. Just remember to take your time, keep everything clean, well lubricated, and refer to your shop manuals. Be sure to verify your repair, do a leak down test, and then take it for a test drive, and make sure everything's fine before you deliver it to your customer. And that's all I had to say about 4-stroke engines.